Okay, this is a tutorial on how to get started on Fusion CAD modeling for those working on the Desk Caddy. I'll give you some tips on how you can model effectively to reduce the amount of dimensioning you require by using constraints and dimensions smartly. So here's an example of what our end result should look like when you guys are done. This one's um, a sample that I've created, and you can see here if I press the play button, it goes through all the steps I took to construct this model. And I'll give you a quick demonstration on how to model up the back piece and the side piece, and you just use the same skills to model up the rest of it. Okay, so you see that's the whole process of making the basic carcass and the base of the Desk Caddy. You can add on more stuff later on if you like, but we're going to keep it simple for the sake of the class assessment task. You also learn how to make a drawing out of this. So you can see here that it creates the drawing from that assembly, and if you update this drawing, if you update the parts, the drawing also updates. And you can add on extra sheets, so you can do detail item drawings of each component, which you will take into the workshop, and that's how we're going to make your job when you have your full set designed and printed. We can then go ahead and cut you timber to make your Desk Caddy. Okay, so this is what we're going to be doing. I'm going to start modeling now. The first thing you should do when you open up a new file is to go to Assemble, and the first thing you should ever do is just start a new component. Before you do anything else, start a new component. Okay, then what you're going to do first is name that component. In this case, I'm going to start with back piece, so I'm just going to go back part, and don't touch anything else. Leave everything as is, and just name it back part. Press OK, and we're going to start modeling up the back part. And the way we start modeling is we start with a sketch, and we're going to choose the plane we are after. In this case, I'm going to choose the front plane here. And our first sketch must use the origin so that we're anchored into this 3D space, this universe that we just created. I'm going to draw a rectangle, and I'm going to model this as a cross section of the thickness and the height, or thickness and the width, and I'm going to extrude the length. So I'm just going to click there, roughly what I need, and then I'm going to go back and I'm going to dimension it. So you can see here the shortcut is D for those of you who are working keenly. Press D, gets you to that tool, dimension, and I'm going to dimension this line here to be 12 mil. That's our thickness. Hit enter, and the height, click, and type in 100. For me, it's 100, depending on your job, right? So for this example, I'm making it 100 tall and 12 thick. Once I'm done, you notice all the lines are black. That's what we're after. Okay, make sure all lines are black before we finish the sketch, so we can't accidentally shift and move anything. So to get out of dimension mode, you can hit escape, and you can see here they're going to highlight the line, but I can't click and drag it because it's fully constrained, right? But if I delete this 100 though, you'll see that this line's turned blue, but all the other lines are black. That means I can't wiggle this left and right because it's constrained as 12 millimeters, defined as 12 millimeters, but I can move it up and down. So that means my height is not constrained, right? It's got no dimension or constraint to hold it down. So I'm going to go back and do that dimension to be 100. And so we've defined this rectangle exactly to be 112, and it uses the origin here, so it anchors it to a 3D space. Finish sketch, and then we're going to extrude this shape. It helps to get to a 3D view, so just on my cube, I'll just click on the corner, get to a 3D view. And just to preview what it's going to be like, I'm going to drag that out, and it gives me a preview of the object. I'm going to make this distance to be the length. I'm using 250. You might be using a different number. And when I'm happy with that, I hit OK. Ignore everything else for now. It's all set correctly. Hit OK, and you've made yourself a rectangular prism that represents our block of wood. Now, the way we model should reflect the way we process the timber in the workshop. So you get your piece of timber, you cut it down to size, and then we're going to mark out the joinery. So I want you to adopt the same type of methodology in your CAD modeling. It helps you understand your parts better, and also helps you work out what dimensions are important to you and when they become available. So you can only really mark out the joints after you've got your block of wood. So now we've got a block of wood. I'm going to create a sketch on this surface. So I can right click, create sketch, right? Or I can go to here and hit sketch, same thing. So if I go here and I go create sketch, I can then start marking out my joinery. So as you saw, I've got a box pin at the back. I'm creating a box pin that is, let's use this bottom corner here. I'm going to draw a few rectangles, right? I'm going to draw rectangles, but I'm going to draw it badly. Let's draw 3 rectangles like that. Okay, right click, OK. So I don't want to be in the drawing tool anymore. And you see here that I can wiggle this line, I can wiggle this line. I can't wiggle this line because it's created an automatic constraint that this line, it knows I want it to be collinear with this edge of this rectangle. So it's made it collinear. But let's firstly define one rectangle. Okay, so we do that with a dimension. So I hit D for dimension. I want this one to be 12 mil because that's the that's the thickness of the side piece that's going to join in. And the height of it, I can do it point to point or a line. In this case, I'll do point to point just for a difference. And I'm going to make this 20. Okay. Now, I'm going to right click and I'm going to press escape so get out of dimension mode just to show you a neat way of dimensioning and using constraints so that you don't have to keep making each one of these 12 mil long. Okay. So there's a few ways you can do it. You can do it via constraints. There are all these different constraints you can use. They create relationships between lines and features so that you don't have to keep on using dimensioning. Okay, so for example, I could want this line to be collinear with this line, right? So if I use collinear in this case, collinear is this one here. So from now until forever, if I click on 1, click on 2, they are now collinear from now until forever. That's the relationship, unless I choose to delete that relationship, okay? Alternatively, another way you could do it is you can make this blue line equal length to this blue line. So let's try that. If I make equal and I go, I want this line to be equal to this line, guess what? It also works because logically, if this is in line, then that distance is the same. So I've made two different constraints here. Ideally, I wouldn't do two different constraints. I would use either make these blue lines here all equal or make these three lines collinear. Both are the same. You end up with the same result. And you can see here that if I try to wiggle this left and right, I can't because it's collinear. But I can move this up and down. And the way we want to find the joint in this case is I'm going to use the datum dimensioning method. So go to dimension. I'm going to use this baseline to this next pin. And I'll make that 40. So we'll talk about datum dimensioning in class a bit more. But essentially what you want to do is think about how you're going to mark this out in the workshop. You'll be using a marking gauge. And the marking gauge has a particular surface that we lean against one of these edges, right? So we call that the datum. So you see here that we're going to have to measure 20 mil, mark that line, measure 40 mil, mark that line, measure 60 mil, mark that line, measure 80 mil, mark that line. Okay, so all my rectangles are now constrained. And I'm using this type of dimensioning because I'm going to use a marking gauge against this edge. And that way I can set the marking gauge to these numbers without having to do quick maths by like adding up numbers here. Okay, either way is, I guess, correct, but this one is going to be more practical for you in the workshop. Once I'm happy with all these rectangles, nothing can be moved. I hit finish sketch. Actually, I'm going to save you a bit more time. I'm going to go back to that sketch. So if you find that you hit finish sketch and you want to go back and edit it, at any point in time, you can just right click on that step here, right? Right click on the step here and edit the sketch. So don't go making a new sketch. You already created the sketch. If you forgot to add something in, just go back and edit and add it in. What I'm going to do is I'm going to create a mirror plane. Okay, so the way I'll do that is I want to use a line tool. I'm going to mark the center point of this rectangle. The center point turns up when the triangle appears. I'm going to draw a line in, and I'm going to make, right click OK, I'm going to make this line a center line, like that. And then I'm going to select these three squares, or three rectangles, and then I'm going to mirror that sketch. And the mirror plane I'm going to use is this right here, allowing me to mirror it to this side, okay? If I do that, that means that constraint has also been applied. And if I edit any of these numbers, like for example, if I edit this number to be, like for example, make that 20, this updates, this also updates, right? So it saves you time not having to redimension and reconstrain this side. So this is how we use the tool smartly. Bring that back to 12, and then I hit finish sketch. So now I can extrude cut these joints out, right? So I'm going to do a 3D view. Holding down Shift and the middle mouse button allows you to rotate like this. Please use a mouse. It helps you out a lot when you're using CAD. So I'm going to extrude, but in this case, instead of operation of new body, I'm going to make it cut. So we want to remove material. So here it allows us to select the things we want to cut. And you see the direction arrow is pointing that way. All you can do is reverse the direction like that to make sure it's in the right direction. I selected 6 of the rectangles, but instead of distance of 40, which is an arbitrary number, we actually go to all. So what that means is the instruction for the CAD program is that we're going to cut away these 6 rectangles all the way through the solid. So no matter how thick our timber is, like pretend we got to upgrade our timber to a thicker material. So let's say it was 20 mil thick. If we use all that, then at this particular point in time when we extrude cutting our joints out, it will cut through all the way through 20 and not just 12. Okay, so all is very powerful for extend type, so it allows you to cut through the entire geometry, the entire physical product we're doing. Hit OK when you're happy, and it's made the back piece. So we're happy with that. I could do a through house too, but I might do that later to show you that we can go back and edit that part later. Okay, so now we've made one part. Okay, I'm going to make the next component. So the first thing we do when we make a new component is we go to assemble, new component. Okay, we're going to rename it right away to be, in this case, it'll be left part. I'm not going to, because, yeah, I'm not going to call it side part because there'll be two side parts and they might be different. They might be mirror imaged. Left part. Okay, and ignore everything else. I'm also going to, actually, I am going to generate it off this surface. Hold on, I'm going to cancel that because there's a reason why I need to select the surface. I'm going to select that face there because I want my new component to be generated off that face. The geometry is going to be useful for me later. So assemble new component, and it says the parent one selected, so that's the parent face it's going to adopt. Here I'm going to put in the left part. Hit OK. All right, so it gives me a chance to select here. So I'm going to select this face right here, okay, because I want my left part to be generated off this geometry. Okay. I'm going to create a sketch on this surface now. The back part's ghosted out because it means the left part's active and the back part's not active. You can make it active by hitting the top like that, okay? But we're actually working on the left part now. So it's that there. On this surface here, I'm going to create a new sketch, okay? Now I'm going to draw a rectangle using the origin. I'm going to make it just slightly bigger than what we need, okay? Press OK. And I could definitely make this side part and dimension it to be, hit T for dimension. I could dimension this to be 100, okay? Which is fine. You can totally do it like that. But what it means is if you happen to adjust the back piece, if you modified your back piece, edited it to be taller than 100, so call it 150, then this side piece will stay at 100 because you defined it as 100. But instead, what you can do is you can generate the side piece off geometry of the back piece. So I'm just going to delete this 100, and I'll show you. So now that that's no longer constrained, I can use constraints across parts, not just within the part, but across the components. So I'm going to make this collinear. I want this edge to be collinear with this edge. And when you see that happen, these purple line appears and these purple dots, circles appear. That's telling you that's referencing geometry from another component, okay? So the left part's referencing geometry to the back part. So if the back part changes size, the left part will also update to be always collinear. What we do need to do is dimension the length of this piece, and we're going to make that 150. Okay, so it's fully constrained or rectangle. Finish sketch. Okay, I'll give you a 3D view to see what's going on. And now I'm going to extrude this piece. I will highlight it. Okay, change direction to be this way. And I can choose to actually to object. I can say project to that object, which is 12. And so no matter what, it will close that gap. You can do it that way, or you can type in 12. Okay, so you can do distance of 12. That's fine too. Either way, you'll get the same result. So if you want to make it smart component, so that no matter what, if you created the joint correctly, you can make it to a component. But in this case, I actually do want to extrude it 12 because I want to make sure that all my parts are 12 mil. It's much difference. If you make this 12 and the joint dimensions change, you have a gap. That's the only difference. But for the sake of this example, I'm going to make this 12. Hit OK, and that's made the new part. Okay, so here's where I purposely left a feature out. Okay, so if you go back to the assembly, you see that it's got an interference here. This piece is actually interfering with this piece. This piece doesn't actually have a gap there. Okay, so what I'm going to do is I'm going to go back to my left part. I'm going to edit the sketch so I can also get rid of this material here. So what I can do is activate that sketch. Right-click this sketch here. I'm going to edit this sketch. And what I want to do is I'm going to create geometry here. I'm going to go draw a rectangle off that line. And then I'm going to use collinear once again and make this edge collinear, this edge collinear, this edge, and this edge collinear. Okay, so it's all referencing it now. Right click, OK, finish the sketch. So what we've done is we've gone back and edited that sketch. I didn't create a new sketch to do that. I went back in time and I edited what I'd already done. And all your features down here, sketches and features, can always be edited. And that's the first thing you should do when you're trying to problem solve, instead of making a new sketch and making a new feature. So here's the feature that extruded that part. I can right click and edit this feature. What I can do is I can click that and it takes that part away. Okay, so you see here that's taken that part away. And then I hit OK. So it's updated it. And now what we've done is we've generated a joint. The side piece, okay, is generated off geometry of the back piece. So the way I can prove that to you is that if I go to my back piece, if I double click there, okay, I say I want to edit that part, okay, I can find the geometry to make it. I'll find the geometry that made the joint. Okay, so the geometry that made the joint is here. That's the sketch there. I can go edit sketch, and let's say I change this geometry here. Okay, so this box here, I'm gonna make it 10. So it's now shorter. If I finish the sketch, look what happens. Okay, the back piece geometry on both sides has shrunken here. So this pin got wider and this gap got smaller. And on the side piece, the corresponding joint lines up still. So it allows you to make changes to a design and not have to worry with updating the part to reflect those changes. Your constraints, if you've planned them well enough, will help you, will make your life easier by updating accordingly to your joint dimensions and constraints. Okay. What else can you do? Well, if you want to extrude further on this as a separate step, I would typically create joints separately. It's each time you make a joint, it's a separate process of marking out, cutting out. But let's say I wanted to cut this on an angle. It's quite simply make a sketch on that surface. Okay, make sure you're in left part though, because we are editing the left part. Create a sketch on this surface, draw a line. Okay, I like to draw the line first and then dimension it. I find it's easier to do that. I can then constrain this point to this line to be a set distance. Let's call that 30, for example, and I'll constrain this point to this distance. Let's call that 50. Okay, so that line's now black. Finish sketch, extrude, select that surface. We'll do cut. Okay, and I'm just going to rotate around, and I will choose the direction this way, but the extent type is through all, so it'll go through all the material. You hit OK, and there you go. It's done it. It's made that angle. So what you got to do is keep that in mind when you're modeling. If you use that technique, it allows you to modify one part and updates the other parts. If you want to go back and change it again, like for example, you find that the joint needs work, find the sketch that you're after. In this case, it was this one. Right? You can always double click. Also works to edit. Double click the part you want to edit. Put in 20 again. Hit finish sketch, and it updates, auto updates. Okay, so I'm going to stop the tutorial here because it's almost 20 minutes, my 20-minute limit of attention span. And you see that if you work well, you end up with something like this, with this many steps, and you can see that it's generated off existing geometry. So that's the advanced way of modeling. You can still model each part separately if you like, but this technique allows you to untap the potential of Fusion. Okay, thank you very much for your time and attention. Let me know if you have any questions. Cheers.